Okay, so we are going to take this to be our example. We try to solve this one based on the empirical formula. So the question goes like this. An organic sample was determined by the following composition: 64.6% of carbon, 10.8% of hydrogen, and 24.6% of oxygen. Determine the empirical formula of this compound. As simple as that. So what are we supposed to do if a question has come like this? I think I just explained something to say, whenever you've been given these percentages, don't even worry. These, in other ways, they can also be said to be what? The masses for every element given in the same question. These can also be what? Can also be your masses given. Okay. So this question, we need to analyze the data first of all that you've been given. What information have you been given in the question? I'll say data here. So we are going to have carbon has been given, or it has a percentage of 64.4%. We also have hydrogen, which is having a percentage of 10.8%, and finally we have oxygen, which is having a percentage of 24.6%. Okay, that information. So I said those percentages, don't even worry about them. Say, how am I going to convert the percentages? These are masses already. For them to get this, what they did was they used what we call the percentage composition. Meaning that I'll write my elements here like this. I'll start with carbon. I'll write my hydrogen here. I'll write my oxygen somewhere there. Right? So what are we supposed to do? I'll just get these masses and write them on top. So I'll say 64.6, have 10.8, do not include the percentages if you want. Then we have 24.6. Right? So I'm going to divide. The first division has to be a division that we are going to divide throughout by, I'll divide every element by its respective number of molar mass. For this one, I'll divide it by 12.01. That one, I'll divide it by 1.01. And finally, this has to be divided by 16. Okay, so I'll start from here. What number are we going to get? If we say 64.4 divide 64.6 divided by 12.01, so I'm getting 5.3788. So I'll write my answer in a form of 4 decimal places. So I'll have 5.3789. all right, I'll come to the one which is in the middle. The one in the middle is given as 10.8 divided by 1.01. It is giving us 10.6931. The last one, which is 24.6, I'll divide this by 16. Okay, so this one is giving us 1.5375. These are number of moles. After dividing like this, everything now, this is the number of mole for hydrogen, number of mole for oxygen, number of mole for carbon. Here, divide throughout by the smallest number to get whole numbers. Okay, which one is my smallest number here? I think basically oxygen is carrying a smallest number. So we are going to say, I'll write this one on top. I'll say 5.3789, 10.6931, 1.5375. I'll divide throughout by the smallest number. So here I'll say 1.5375, 1.5375, and 1.5375. Okay, so here we are going to get 1. So we are going to get, now we are getting 1 for this side. Okay, and then here if you say, I'll divide it like this. I'll say 10.69.31, divide this by 1.5375. Sorry, 10.6931, divide this by 1.5375. we are getting an answer as 6 point. So in the middle, I'm getting my answer as 6.95. Okay. Now come the first one, which is 5.3789. Divide this by 1.5375. So here we are getting an answer as we are going to have 3.5 to say. 3.5 to say. So if you check this one, we shouldn't be troubling ourselves with this number. We can't go beyond this. This can just be rounded off. We are going to have 7 automatically. But this can't be rounded off. This you can't round off that same number. What are we supposed to do? This is what I was saying. Do not round off a number which is having a range of decimal places from 0.2 to 0.8. So this number, the way you can write this number, this can just be one and the same, like 7 over 2. Meaning that here I'm going to write it in a form of a fraction like this. To get rid of this fraction, I'll multiply now throughout by 2. We are going to say 7 over 2. Here I'll write 7. At the end I'll write 1. What I mean if I say we multiply throughout by 2 is this. I will do like this, so that whenever I say 2 multiplied by 7 over 2, these 2 and that, they are going to be cancelled. You are going to have 7. This multiplied by that, we are going to have 14. And this multiplied by that, we are going to have what? 2. That's how we multiply. If I say you need to multiply throughout by what? By a certain factor which is going to reduce this number to a whole number like this one. Meaning that C H O is going to have the subscripts of what? 7, 14 and 2. Finally, this qualifies to be my empirical formula. That qualifies to be our empirical formula. So the question continues. They are saying, given that the molar mass is about 162 grams per mole, what is the molecular formula? This is my empirical formula. Now they are saying the molar mass is found to be 162 grams per mole. We need to find what we call molecular formula. How do you find the same molecular formula at this moment of time? To get the molecular formula, you must know to say, you need to understand what will be the empirical mass. Whenever I say the empirical mass, I simply mean the molar mass for this compound, which is my empirical formula. So I'll say 2 multiplied by 16, 14 multiplied by 1.01, 12.01 multiplied by 1. What is our total number of the moles? Or the molar mass? we are having now something like 2 multiplied by 16, get that, plus 14 multiplied by 1.01, say plus 12.01, and here we are getting 58. We are getting 58.15 grams per mole. So what I said, if you want to find a factor and you want to diverge from empirical formula to what we call molecular formula, what you should always be doing is you need to know that
for carbon is that 1 or 7?
Oh, sorry. We made a mistake here. So okay, we make a correction. This has to be 7. Thank you very much for your correction. So we are going to have 12.01 multiplied by 7, okay, plus, okay, I'll say plus 32 plus 14 multiplied by 1.01. Okay, thank you very much. So instead of us getting this, the molar mass that we are going to have has to be 130.21 grams per mole. So to get the factor, what we said, you have to divide this molar mass into the molar mass given in the question. They have given us to say the molar mass given in the question has to be something like this. So I need to get a certain factor which is going to be n. And how do you get n? N is going to be equal to the molar mass over the empirical mass. And to find the molecular formula, you say empirical formula multiplied by n. So first of all, you need to get n. How do you get n? You divide the given molar mass in the question, divide by the what? The molar mass we are from getting for this empirical formula. So my n here is going to be equal to 162 over 130.2. Okay, it has to be 21 if I'm not mistaken. Yes. So the answer, the calculator kept the answer. I'll just say 162 divided by the answer. So we are getting our answer as 1.24, of which this answer is going to be what? It has to be 1.2. Okay, so if you reach at this given point, if you multiply this given factor, let me just repeat this if we made a mistake. This number which is here, if you want to get the empirical formula, this number which is here, you must multiply by a given factor which is going to convert this one not to be in a form of what? Not to be in a form of decimal places that are ranging or that are having a range of 0.2 to 0.8. So there is only one factor which can make this one be in a form of a single number. What is that? That same factor is 5. If you multiply this by 5, definitely, if I say 1.2 multiplied by 5, I'm getting 6. I'm definitely getting a 6. Meaning that this 6 I'm from getting has to be the actual number for n. So to diverge from empirical formula to molecular formula now, if you want, you can even still leave it like it, you just get 1. Molecular formula doesn't have any effect as compared to empirical formula. If you leave it like you say, you pick 1, still meaning that you are going to divide. You are going to divide, or you are going to cancel out certain numbers until you return to this same thing. So I'm saying your empirical formula can, molecular formula can also be, or it can be C7H14 O2. You multiply the subscripts by 6, of which if you say this multiplied by that, the number is going to be so bigger. To reduce it, it's more like you're also dividing throughout by what? By 6. You are going to return to this one. To avoid writing bigger numbers, you can just divide by the smallest number to reduce the subscripts, and hence it will give you something which is going to be very small. So even this is it can be marked, including that they can also mark. they can also mark. Okay, so I think this has to be last question to be solved. So the number has to be 1.85 times 10